Hello and welcome back to the course. In this lecture, we're going to take a high-level look at the game architecture and course structure. This will help you understand what we will be doing in each section of the course and how all the elements of the game fit together. In the Dungeon Room Editor section, we will build a Dungeon Room Editor tool that will allow us to build node graphs of Dungeon Room layouts for our dungeon levels. We will start by creating a simple editor window and then add functionality until we have a fully featured dungeon level room node editor. In the editor, you'll be able to add room nodes and create parent and child relationships by dragging connecting lines between nodes. The Dungeon Room Editor tool will create scriptable object assets for the completed dungeon level layouts. In the main game scene setup section, we'll set up the main game scene, creating our main camera and configuring the Cinemachine and Pixel Perfect components. In the Dungeon Room Template section, we'll look at layers and sorting layers and how we'll use them in our 2D game. We'll create a base Dungeon Room template using Tilemap layers as a base for creating our dungeon rooms. We'll look at the tools Unity provides to work with tile maps, tile palettes and tiles. We'll create our first dungeon room using layered tile maps and then set up all of the dungeon rooms we are going to use in the game. We'll create scriptable objects to describe the attributes of our created rooms. In the Dungeon Builder section, we'll explore an algorithm to randomly create dungeon levels using our dungeon room templates and our dungeon level node graphs. We'll create a Dungeon Builder class that will create entire dungeon levels by randomly selecting dungeon level node graphs and dungeon room templates and laying them out into complete dungeon levels. Once we have successfully laid out a dungeon level, we'll instantiate dungeon room tilemap prefabs to build our completed level in the scene. In the initial player setup section, we'll create the initial player classes and the base player prefab. The player prefab will be structured to support weapons and the various player movement animations and the animation states defined in the animator controllers. We'll use scriptable objects to define the player attributes. In the player movement and control section, we'll start using events to control our game functions. We'll add weapon aiming for the player to follow a target screen cursor and implement player movement using the WASD keys. We'll add the dodge roll maneuver for the player and we'll enhance Cinemachine to track our weapon aiming cursor as well as the player movement. In the dungeon doors and lighting section, we'll add doors to the dungeon room doorways, which will open as the player approaches them. We'll control the lighting of dungeon rooms and doors to only fade them in to be visible when the player approaches them, to give the sense that rooms are initially unexplored. In the object pooling section, we'll look at the concepts behind object pooling and how it can improve the performance of some games. We'll implement an object pool manager that we'll use throughout the course to pool prefabs that we want to reuse. In the player weapons and ammo section, we'll implement player weapons and ammo. This is a big section of the course. We'll start by looking at the weapon and ammo classes we'll be using to support the player shooting functionality. We'll use an emission shader to add an HDR glow to ammo. We'll use scriptable objects to define the attributes for the weapons and ammo. We'll implement weapon shooting and reloading and create the player weapon status UI. In this section, we'll implement all the player weapons for the game. In the sound effects section, we'll look at how Unity handles sounds and audio and how we'll implement sound effects in our game. We'll create the core classes to play sound effects and then we'll implement weapon shooting and reloading sound effects. We'll also add sound effects for things like the dungeon doors opening as the player approaches them. In the minimap section, we'll implement a minimap window in the game UI to show a zoomed out view of the player and surrounding dungeon rooms. To do this, we'll create a new camera that will be configured to only render objects on the minimap layer to display our minimap. Rather than this camera rendering to the screen, it will render the minimap to a texture which will be scaled down and then displayed in the game UI. In the weapon and ammo special effects section, we'll implement weapon and ammo special effects, like smoke when a weapon is fired, and hit effects for the ammo. We'll use Unity's particle system to create these effects. We'll use prefabs and scriptable objects to create base particle effects that we can tailor for specific effects like the shoot effects and hit effects for the ammo. We'll then implement these effects for our weapons and ammo. In the enemy setup section, we'll start implementing our enemy and boss characters and start adding the functionality they need for the game using a component-based approach like we did for our player. We'll create the prefab variants and enemy details scriptable object assets for all the enemies in the game. In the enemy animation section, we'll set up the animator controllers and animations for the enemy and boss characters. In the A-star pathfinding section, we'll implement the A-star pathfinding algorithm that we'll use in the game. We'll explain how the A-star algorithm works and talk through an A-star pseudocode algorithm. We'll then use the A-star demo program included in the resources to further explain how the A-star algorithm works. We will then code the A-star pathfinding algorithm in the game and then add obstacle collision tiles from the tile maps for the algorithm to avoid non-walkable areas. We'll also add preferred paths to the A-star algorithm to better control where enemies can move. In the enemy AI movement section, we're going to use the A-star class we've built to move enemies around the dungeon room on a path to follow the player. In the spawning enemies section, we're going to add the functionality that we'll need to be able to define how enemies are spawned in different rooms and use a materialize effect when we spawn them. We'll set up room template scriptable objects to hold details of which enemies to spawn for a room for a particular dungeon level. We'll automatically lock the doors when a player enters a room and spawn the enemies, only unlocking the doors when all the enemies have been defeated. We'll use a materialize shader to create a materialize effect when enemies are being spawned. We are also going to use the Unity profiler to help us optimize the enemy A-star pathfinding. In the enemy weapons and ammo section, we're going to implement weapons for the enemies in the game. We'll start by looking at how we're going to implement weapon aiming and firing for enemies by reusing the components that we've already built for the player. We'll use scriptable objects to hold the enemy weapon details. We'll implement a new enemy ammo prefab and we'll update the enemy scriptable objects to hold details of weapons for the enemies. In the health and damage section, we'll look at the concepts we'll use to implement health and damage in the game. In a dungeon shooter, a fundamental mechanic is that ammo fired from weapons will cause damage to the player and enemy health. As well as ammo causing damage, contact with the enemies and the player can also cause damage. We'll implement the player health UI that uses heart icons to show how much health the player has remaining. We'll implement immunity from damage for the player when the player performs the roll maneuver. This will be an important way for the player to avoid damage when clearing the dungeon rooms of enemies. In the battling through levels section, we're going to enhance our gameplay to keep track of scoring and enable the player to battle their way through the whole dungeon. We'll add a scoring multiplier effect to reward more accurate shooting. We'll only make dungeon rooms visible as they appear in the minimap to improve the game running efficiency. We'll allow the player to progress through the whole dungeon level, clearing rooms so they can battle the boss. After battling the boss, we'll allow the player to progress to the next dungeon level. In the decorating the dungeon section, we're going to decorate our dungeon rooms. We're going to create a number of different dungeon items that we can use to decorate the dungeon. These items will have health components attached and can take damage from ammo and also contact damage from the enemies and player. Each item will have an animation that plays when it's destroyed. We'll also create some flickering dungeon torches using a shader graph, Flame Shader. In the movable objects section, we're going to create objects that can be pushed and moved by the player. This includes tables that can be flipped to give the player some cover from enemy fire. The tables will have animations that play when they are flipped by the player. In the enemy ammo patterns section, we're going to implement enemy ammo patterns. For some of the enemies, rather than firing a single ammo shot, they will fire patterns of ammo, such as snakes, spiders, squares, triangles, and stars. In the dungeon chests section, we're going to implement dungeon chests that the player can loot. These can contain health, ammo and weapons. Dungeon chests are important for our gameplay and will be either positioned at strategic points throughout our dungeon levels or automatically spawned when enemies are defeated. Chests will be spawned by a chest spawner class and prefab that can be added to dungeon room prefabs to automatically spawn chests based on the spawning parameters that have been specified. In the dungeon overview map section, we'll create a new dungeon overview map that will be displayed by pressing the tab key. The player can navigate to rooms they've already visited by clicking on a room in the dungeon overview map. This will allow the player to quickly navigate between rooms that they have already visited, which is especially useful in a large dungeon level. In the game music section, we'll revisit the audio concepts and look at how we're going to use those concepts to implement music in our game. Music is an integral part of any game and helps to set the mood and atmosphere. We'll use scriptable objects to hold details of music tracks, and we'll amend the room template scriptable object class to hold a reference to the ambient and battle music track that should be played for a room. We'll build a music manager that will play the music tracks and control the fading in and out of the music using audio mixer snapshots. In the pause menu section, we're going to implement a pause menu for the game triggered by pressing the escape key. The pause menu will add the ability to adjust the music and sound effect volume levels and save the set levels using player preferences. In the main menu section, we'll create a main menu for the game that will be loaded when the game starts. We'll add a character selector to allow the player to choose the character they want to play the game with. We'll also add the functionality to keep track of the high scores and add an option to the main menu to display them in a high scores table. We'll also add an option in the main menu to display some instructions on how to play the game and also add a quit button to end the game. So I hope that gives you a good understanding of what we'll be covering in the course and the game architecture that we'll be implementing. So I look forward to seeing you in the next lecture to get started.